Find sine alpha if tangent alpha is -2. We have done this with acute angles, but we have to revisit that too. But it's usually not as problematic as the basic trig equations we just did. First, focus only on the sign. Focus only on the, and by sign, I mean the one with the G, plus minus. If tangent is negative, that places our angle into, you can think of the line slope, it's this, the second and the fourth quadrant, right? Where it's equally likely, or it's equally possible to have the same congruent triangle upward or downward. So sine alpha could be positive or negative, right? So sine alpha could be positive or negative. Am I getting right? Yes, I'm getting it. Now ignore the sign and solve as before. So draw a triangle where tangent alpha equals 2 can happen. Here is alpha 2 and 1, right? Find the hypotenuse, looks like square root of 5 to me. So then sine alpha equals to 2 over square root of 5. And now consider the signs. The answer is sine alpha equals plus minus 2 square root of 5. Because there is nothing in the problem that distinguishes which one out of the two. Now, you know, if you want the answer unique, you're gonna look for stuff, and alpha is not in the fourth quadrant. You know, it's not, it's a little bit lame. It's basically gonna rule out one of the two possibilities. So if the problem says, so for a unique answer, find sine alpha if tangent alpha equals to -2 and alpha is not in the second quadrant. This is the second quadrant. Then it was a not very sophisticated way to rule out quadrant 2. So really we are here, which means the cosine is positive, the sine is negative, right? Then we know, but we do the same thing. I just don't want to rewrite it. We ignore the signs, solve it as if it was acute, and then we come back and say plus minus, and depending on where in the unit circle, we're going to say sine alpha is -2 over square root of 5. And also note that sine alpha is no longer square root of 1 minus cosine squared alpha. It's that or its opposite. Given only sine alpha, we can never uniquely find cosine alpha, just up to a plus minus. That's the payment for such a big domain as the unit circle domain. Any questions about this